So we have discussed about polar coordinates. Polar coordinates consists of two coordinates. One is r, that is what we call radial vector, and another one is theta. Theta denotes the angle between the initial line and the radius vector. The radius vector is nothing but the shortest distance from pole to the point P. So if the point P has coordinates r and theta, r is the radius vector from pole to the point P, and theta is the angle between the initial line and the radius vector. A relation of the type r is equal to f of theta, where theta is taken as the independent variable and r is taken as a dependent variable. So r is equal to f of theta defines a curve in the plane. And to change the coordinates from Cartesian coordinates xy to the polar coordinates r and theta, a substitution is required. That is, x is equal to r cos theta we substitute, and y is equal to r sin theta we can substitute. So to interchange the Cartesian coordinates xy to the polar coordinates r and theta, we use the relation x is equal to r cos theta and y is equal to r sin theta. So let us try to solve these examples. The first one is x cube plus y cube is equal to 3x square. So here you substitute x is equal to r cos theta, y is equal to r sin theta, and in the equation x cube plus y cube is equal to 3xy, it becomes r cube into bracket cos cube theta plus sin cube theta is equal to 3a times r square into cos theta sin theta. Of course, you can factorize both LHS and RHS, and you may convert it as in the form of r is equal to f of theta. Similarly, you can also consider the second equation x to the power 4 plus y to the power 4 is equal to 4a square into xy, and the third one is x to the power 4 minus y to the power 4 is equal to 4xy. So you try to convert these equations. These equations are in Cartesian coordinates, and you need to change it to polar form by substituting x is equal to r cos theta and y is equal to r sin theta. Of course, in the next class, we'll be giving you the solution. Now we'll consider the point P with the coordinates r and theta on the given curve r is equal to f of theta. We transfer to Cartesian coordinates and obtain r is equal to x cos theta. That is, we can write it as f of theta into cos theta, because the given equation is r is equal to f of theta. So in place of r, we will be substituting f of theta. So we have x is equal to f of theta cos theta. Similarly, the relation y is equal to r sin theta can be written as y is equal to f of theta into sin theta. Further considering x is equal to f of theta cos theta and y is equal to f of theta sin theta as the Cartesian parametric equations of the given curve with theta as the parameter, we note that the tangential angle tan psi, of course for any curve we know that for the curve y is equal to fx, tan psi will denote slope of the tangent. So tan psi is equal to dy by dx. So as y is a function of theta, x is also a function of theta, we can write both dy by dx in terms of dy by d theta and dx by d theta. So I have written dy by dx is equal to dy by d theta divided by dx by d theta. So what we are doing here, this is the curve r is equal to f of theta is the given curve. R is equal to f of theta is the given curve. Ox is the initial line. Ox is the initial line, and OP is the radius vector. OP is the radius vector. So the angle POX is denoted by theta is called vectorial angle. And the angle, say, PMX, it is denoted by psi. So this angle is the angle between the tangent vector and the initial line. What we require? We require the angle between the radius vector and the tangent vector. We need to find an expression for the angle between the radius vector and the tangent vector, that is denoted by pi. So this angle pi is the angle between the radius vector and the tangent vector. So for this we use the expression tan psi is equal to dy by dx, and we write in terms of dy by d theta divided by dx by d theta. Now again substituting y is equal to f of theta sin theta and x is equal to f of theta cos theta. So the numerator is derivative of f of theta into sin theta, and the denominator is derivative of f of theta into cos theta. So we write sin theta as it is, derivative of f theta is f dash theta, plus f of theta as it is, the derivative of sin theta is cos theta. In the denominator we have derivative of f of theta cos theta. So here cos theta as it is, derivative of f theta is f dash theta minus f of theta into the derivative of cos theta is sin theta. Then divide both numerator and denominator by f dash of theta into cos theta. So LHS will be tan psi, but RHS changes to tan theta plus f of theta divided by f dash of theta whole divided by 1 minus f of theta divided by f dash of theta into tan theta. So call this as equation 1. Also noting that the angle between the radius vector and the tangent vector from this diagram you may note that this angle psi is sum of theta and the angle between the radius vector and the tangent vector pi. Of course these two angles are opposite angles, therefore they must be same. So the angle opposite to theta is nothing but pi, and psi is the angle outside the triangle. So we have psi is equal to pi plus theta. Psi is equal to pi plus theta, that you have to remember. Psi is equal to pi plus theta. So we use the same relation, psi is equal to pi plus theta, and therefore tan psi is equal to tan of pi plus theta. Tan psi is equal to tan of pi plus theta, and therefore tan of pi plus theta is equal to tan pi plus tan theta divided by 1 minus tan pi into tan theta. Tan of pi plus theta is equal to tan pi plus tan theta divided by 1 minus tan pi into tan theta. So looking at these two equations 1 and 2, looking at both the equations 1 and 2, you may note that tan psi is the same on LHS. So RHS must be the same. So we equate RHS of both the equations. And we also see that there is a word tan theta. There is a word tan theta in both the expressions. Leaving that tan theta expressions, we see that tan pi is equal to f of theta divided by f dash of theta, that is d by d theta of f of theta. F dash of theta is nothing but d by d theta of f of theta. So we have f of theta is r, so r is written in the numerator. F dash of theta is nothing but dr by d theta, or we write it as r dash. So r by r dash is equal to tan pi. This is an important relation. Tan pi is equal to r divided by r dash is the important relation, and